A warm welcome to all the viewers. Today's session of tourism and hospitality research is going to be a special again. Why? Because we are going to see how to assess the multivariate normality in SPSS through a graphical method. Isn't it surprising? For all those out there and all young researchers, this could be quite useful for you in your research. So today I'm going to show you how you can easily assess the multivariate normality in SPSS without the syntax function. So let us start. So this is the paper which I came across recently, which says the graphical assessment of multivariate normality using SPSS. The paper was published in June 2015 in the Journal of Education in Medicine Journal. The author has very clearly and simply described the procedure to conduct the multivariate normality assessment in SPSS by comparing the chi-square value with the Mahalanobis distance and plotting it on a scatter dot graph. So this is the paper which lists down all the details of how to conduct this analysis. You might go through this paper as I found it quite valuable. So let us see how the paper has described the analysis of multivariate normality using SPSS. So here we are in our SPSS and once again working on the same data which I am showing you throughout all my video examples. The first is FQ food quality measured on Likert 5-point scale. 4 indicators of food quality FQ1 to FQ4, cultural authenticity CA1 to CA4, service quality SQ1 to SQ4, value for money VM1 to VM4, and behavioral intention of tourists BI1 to BI4. So we have 5 variables, 5 latent variables, each having 4 observed variables or indicators. That makes a total of 20 observed variables in our study. So what should we do to assess the multivariate normality? Although it is prescribed to check the multivariate normality in AMOS, and many researchers claim that it cannot be tested in SPSS, but the paper which I showed you describes the steps on how to indirectly assess the multivariate normality using SPSS in case you don't know how to work well with AMOS or you don't have the software AMOS at your disposal. So what we need to do? So the first step is to calculate the Mahalanobis distance of all my observed variables. So I'll go to analyze, regression, linear, and in the dependent I'll put the case ID. It's a dummy variable, and all my 20 observed variables are put in here. You can see here all 20. How to put them? I'll just show you once again. I'll put them back, and now I select FQ1 and I press shift button and click on BI4. So all 20 are selected and I put them in independent. I go to save and I click on Mahalanobis distance. I click on continue and press OK. Again, go back to the data sheet and there's a new variable created for me, that is Mahalanobis distance. So this is the Mahalanobis distance. I arrange it in ascending order. So I've arranged it in ascending order. Now what next I need to do? I'll again go to transform. Now I will go to transform compute variable, and now I'm going to find out the probability value. For that purpose, I need to enter the formula, which is this dollar case number. So I'll go to dollar case number. Within the brackets, I have to put this minus 0.5. Close this, and as we have 204 observations, so I'll put it 204 divided by 204. That is the number of observations I have in my data. I press on OK. Again, go back to the data sheet. Now you see variable P, probability value, has been created. Now what is the next step? Again, I go to transform, compute variable. Now I'll generate the chi-square value for the P value which I have generated. How to do that chi-square value? I put chi-square in target variable. Then I have to select inverse distribution function of chi-square distribution for specified degrees of freedom. Here the degrees of freedom means the number of observed variables, that is 20 in my case. So I'll go to all and I'll find that function, that is IDF. IDF dot chi-square. This is the function I want to use. And then in the first question mark, I have to put in the P value. I'll put in the P value. And in the second, after comma, I'll put the number of observed variables, that is 20 in this case. I'll click on OK and again go back to the data sheet. Now I have the chi-square value. So what is the last step? The last step is to draw a graph, plot it on a scatter dot, simple scatter dot graph, to see if my distribution follows a multivariate normality structure. Then I would be getting a straight line on a plot of chi-square on the y-axis and Mahalanobis distance on the x-axis. How to do that? Go to graphs, legacy dialog, scatter dot, simple scatter, define, and now on the y-axis I'll put the chi-square value which I have generated, and I'll put the Mahalanobis distance on the x-axis. So now I'll click on OK and I'll get the graph. Now you see it seems to be quite a straight line with little deviation at the ends. So I double click it and click on add fit line at total, and now you see that there is a fit line and most of the points lie on that fit line. So we can infer that our data follows multivariate normality assumption, and we can go ahead with the analysis of the data in case we want to do regression or ANOVA, where multivariate normality is an important assumption. So I hope this session was quite useful for you, and you will definitely share it with your friends and faculty colleagues. Keep learning and keep watching for more. Thanks a lot.